The quiet war, the never-ending battle between metal and corrosion, goes on. This program is the second in the two-part series, Identifying and Treating Corrosion. Part 2 of this series will outline the general procedures that are to be followed for treating various types of corrosion. Bear in mind that each type of corrosion and each type of metal is unique and requires special treatment. The specifics for aircraft corrosion are spelled out in the 509 manual, NAVAIR 01-1A-509. The specifics for avionics corrosion are spelled out in NAVAIR 16-1-540. And the specifics for ground support equipment corrosion are spelled out in NAVAIR 17-1-125. But no matter which manual you use, or what type of corrosion or metal you are dealing with, the important point to remember is this: corrosion shall always be removed by the mildest means possible. Generally speaking, effective corrosion treatment calls for cleaning the aircraft, inspecting it for corrosion, documenting the location and type of corrosion found, removing paint from corroded areas that are painted, removing the corrosion, surface preparation, surface treatment, the application of sealants, and repainting surfaces that require paint. Let's take a closer look at each of these 9 steps. The first step, cleaning, is an absolute necessity. Cleaning the aircraft is the most important requirement of the corrosion control process. Cleaning the aircraft is both necessary for proper corrosion inspection and treatment, and beneficial as a means of preventing corrosion in the future. Remember, good preventive maintenance is the best corrosion treatment there is. After the aircraft has been cleaned thoroughly, inspect it carefully for the telltale signs of corrosion. The importance of good, thorough zonal inspection cannot be overemphasized. You can't treat it until you find it, so take the time to look everywhere and conduct a good, thorough corrosion inspection. Throughout the inspection process, document the location and type of all existing corrosion and all potential corrosion, such as bare metal or chipped paint, recording your findings on the appropriate zonal chart. After the inspection process is complete, you will transfer the documentation of all existing corrosion from your zonal charts to a maintenance action form, known as a MAF. And you will transfer documentation of all potential corrosion, those areas requiring preventive maintenance measures, from your zonal charts to a support action form, known as a SAF. With the inspection and documentation procedures complete, your next objective is to remove the paint from corroded areas that are painted. Paint removal makes it easier to determine the depth of the corrosion and to identify the extent of damage. Paint removal can be accomplished either chemically or mechanically. The type of corrosion, its location, and the extent to which it has advanced will likely determine which of these methods is employed. But remember, paint removal shall be accomplished by the mildest means possible. It is for this reason that chemical paint removal is the most preferred means. To remove paint chemically, first, surround the affected area with chemical-resistant tape. mil-T-23397, type 2, in the manner shown here, to prevent runoff of the chemical remover. Before opening the paint remover, you must don the necessary protective clothing. You must wear coveralls. Then put on a respirator. Next, put on a face shield. And finally, a pair of protective gloves. Warning: a full face shield must be worn at all times during this portion of the corrosion treatment procedure. Goggles do not provide full face protection and are not to be substituted for a full face shield when working with chemical paint remover. Caution: gas buildup inside unopened cans of paint remover may expel contents when cans are opened, so protective clothing, a full face shield, and gloves must be donned before cans are opened. Chemical paint remover must be used in an area that is both shaded from the sun and well ventilated. Never use chemical paint remover in direct sunlight. Consult the 509 manual for warnings and cautions about the use of chemical paint remover before you begin the paint removal process, and note the shelf life date of the chemicals you are about to use. If the paint remover has exceeded its shelf life, don't use it. Substitute it with an up-to-date supply. Warning: do not use chemical paint remover on fiberglass or plastic. Watertight or fuel-tight seams, fabric, hydraulic lines or hydraulic components, or sealants, unless you intend to remove the sealant in order to treat the area for corrosion. Apply the chemical paint remover using a fiber brush. Allow the paint remover to remain on the corroded surface until the paint wrinkles, usually 10 to 40 minutes. Reapply paint remover as necessary and scrub hard to loosen paint using a non-metallic scraper. When paint is loose over the entire area, wash the area clean using fresh water and neutralize the paint remover by rinsing the area with an alkaline solution of 9 parts water to 1 part Mil-C 85570, type 2 aircraft washing compound. If chemical paint removal is not possible, the paint will have to be removed by mechanical means. Note: prior to using any type of abrasive for mechanical paint removal or corrosion removal, you must don a respirator and eye protection, either goggles or a face shield. To remove paint mechanically, you will use either a handheld abrasive, such as an abrasive mat, or an aluminum oxide cloth, or a mechanical abrasive, such as this vibrating sander, or this flat brush. This example will demonstrate the use of the flat brush. Caution: when using the flat brush, apply minimum pressure. Do not remove any more paint than necessary to treat the corroded area. With the paint removal procedure complete, your next objective is removal of the corrosion itself. First, hand scrub the corroded area with a dry, non-metallic brush. Then go over the area with a handheld abrasive mat, Mill A9962. Then hand rub the area with an aluminum oxide abrasive cloth of the appropriate grit. If the corrosion persists, go over the corroded area with a flat brush. For hard-to-reach areas, remove corrosion by using an aluminum oxide abrasive cloth, 320 or 240 grit, on a mini mandrel. Corrosion removal from pits or irregular surfaces of the aircraft may call for use of the vacuum-blast machine. Warning, it is mandatory to wear a respirator and eye protection when operating vacuum-blast equipment. Vacuum-blast is not to be used for removing paint. Removal of severe exfoliation corrosion from aluminum or magnesium components may require the use of an abrasive wheel, Mil-W-81319. When the corrosion removal process is complete, your next objective is surface preparation. First, clean the area with a clean abrasive mat, Mill A9962, saturated with water. Then, rinse the area thoroughly with fresh water. Pay particular attention to fasteners and any other areas which may entrap residues. At this stage of the process, the surface should be free of water breaks. If, after rinsing, the surface is not free of water breaks, reclean the area with a solution of 9 parts water to 1 part aircraft cleaning compound. Then rinse with water. The surface should now be free of water breaks. Immediately following the surface preparation phase of the corrosion treatment procedure, the surface treatment process must begin. Surface treatment, also known as chemical conversion treatment, is an extremely important part of the corrosion control process. During this process, chemicals are applied to the metal surface while the surface is still wet from rinsing. These chemicals provide considerable corrosion resistance and, if the metal is to be painted, greatly improve the adhesion properties of the paint. Section 5 of the 509 manual tells you which chemical conversion coating materials are to be used for the particular type of metal surface you are treating. It also tells you the correct color change to watch for, the color change telling you that the desired chemical conversion has taken place. After applying the appropriate chemicals, wait and watch for the chemical conversion process to take place. Chemical conversion is indicated by a change in the metal's color. When the correct color change is achieved, rinse the area with plain water. If you are treating a surface that requires paint, allow the chemical conversion coated surface to dry for 30 minutes before repainting. The coating will remain soft until it is dry. Do not wipe the surface with a cloth or brush. Wiping will remove the protective coating. With the surface treatment process complete, if necessary, the application of the proper sealant can begin. Sealants are protective coatings that are applied to seams and veined surfaces to protect them from moisture. Consult Section 5 of the 509 manual for details regarding the type of sealant to be used, the correct application procedure, and the drying time required for each method. Sealants may be applied with a brush, a spatula, or a spray gun. The final step in the corrosion treatment process is the priming and repainting of those surfaces from which paint was removed in order to treat for corrosion. Section 6 of the 509 manual details everything you need to know about priming and repainting, including surface preparation procedures, the uses and application techniques of various types of paints, the use and care of equipment, and the causes of defects and the application of various paints and methods for preventing such defects. Remember, cleaning, inspecting, documenting, paint removal, corrosion removal, surface preparation, surface treatment, the application of sealants, and repainting. These are the fundamentals of effective corrosion treatment.